Hello, this is Mr. Best. Welcome to Chapter 1, Homework Questions 25 through 29. Question 25. Frida function has another quadratic function for you to investigate. Graph the equation y equals x squared plus 3 and then answer the questions from problem 1-23. So going back to 1-23, you were asked as a team to describe a certain quadratic function. And as you did that, they had some questions for you to answer, and that's what we're trying to do as well. So given a new equation, y equals x squared plus 3, let's go ahead and graph this. You can use Desmos to help you. So that's this part right here. You can click on that link, and it will help you graph. If not, we can use a table. So we'll take y equals x squared plus 3, and I'll use a table to graph it. Once again, you can use Desmos or a graphing calculator to help you as well. So what we're going to do is we're going to plug in a couple of values here. I'm going to do -3, -2, -1, 0, 1, 2, and 3. And when you square -3 and add 3 to that, you get 9 plus 3 is 12. And then we're just going to keep doing this throughout the entire table. We're going to square to the x and then add 3. So -2 squared is 4. 4 plus 3 is 7. -1 squared is 1. 1 plus 3 is 4. 0 squared is 0. So 0 plus 3 is 3. 1 squared is 1. 1 plus 3 is 4. 2 squared is 4. 4 plus 3 is 7. And 3 squared is 9. 9 plus 3 is 12. So hopefully one of the things that you recognize, whether on the table or the graph itself, is that you see these y values repeat, and then there's usually one, or always one, in the middle of all these numbers. And so what we're going to do is we're going to take these points and first graph them. So -3, 12 doesn't really fit on my 10 by 10 graph, so I won't graph that one. -2, 7 is right here. -1, 4. 0, 3, 1, 4, and then 2, 7. And so I'm going to go ahead and graph. And as x continues to go on, so does the y. So I'm going to put arrows on my graph. And then we want to answer the questions from the problem 123, our core problem that we worked together as a team. And so part of that was you were just going through and describing some of the things that you noticed. What does the shape look like? It's a U-shaped graph, or maybe you called it a parabola. So we're going to start writing some of this stuff down. The graph is a parabola. We'll use the correct terminology there. But if you said U-shaped, that's fine. It is a parabola, and how does it open? You really have two options. It can either open up like this, or it could open down like this. So this is what we consider opening down. This one would be considered opening up. Another thing that we discussed is the symmetry that can occur. And so for this graph to be symmetric, we want to take it and fold it over that line of symmetry. So right here, you have a line of symmetry that splits the parabola in half. You can see this is 1 unit away here, 1 unit here. This point is 2 units away, and 2 units away. So it's symmetrical on each side. So we know there is a vertical line of symmetry. We can name it a couple different ways. If you want to say it goes through the point 0, 3, that's fine. If you want to actually name the line, this would be at x equals 0. So either way would be fine. As we continue on, we also might notice that we have a minimum value right here. This is called the vertex of a parabola. And the vertex either represents the min or maximum, and in this case it is the minimum value that you can have. The graph does not go below that point. So there is a vertex at the point 0, 3, and it is the minimum value. The other thing we want to look for are intercepts, and the intercepts we want to look at either across the x-axis or the y-axis. So we want to look for any of those. Now you can see the parabola in this case does not cross the x-axis anywhere, so there are no x-intercepts. There is a y-intercept. It actually happens to be the minimum or the vertex as well at 0, 3. So no x-intercepts, but we do have a y-intercept at the point 0, 3. All right, so for now, that is probably as much as we can do in terms of describing. We will continue to add things that we can use to describe all graphs, not just quadratics or graphs that look like a parabola or are a parabola. So there's kind of the things that we had discussed in question 23 and did it again on question 25. Question 26, more diamond problems. Copy these and use the pattern you discovered earlier shown at the right to complete each of them. Some of these may be challenging, which is perfectly fine because that's how we're going to learn. On part A, once again, what multiplies in terms of x and y to get the top number and what adds to get the bottom number. Since we have both of them, we can multiply those two together to get negative 66, and we can add them to get negative 5. Part B, once again, multiply. Negative 1 times negative 4 is 4. Add negative 1 plus negative 4, and that is negative 5. Part C, we don't know what the x is, but since we know it's x times negative 2 should equal negative 6, what times negative 2 would give you negative 6, and that would be a positive 3. So we know that this value is a 3. 3 times negative 2 is negative 6. And I wrote it out, but you can also just do it in your head if you know what multiplies negative 2 to get negative 6, so that's fine. Now add to get the bottom number, and that would add to give you 1. On part D, we don't have the x or the y. We've done these before. We just got to ask ourselves what multiplies to give us negative 8. But what adds, those same two numbers add to give us negative 7. And we always start with the multiplication first because there's not as many factors or ways that you can multiply to get negative 8 as there is to add negative 7, at least not with nice numbers. So what times 8? Well, we have 1 times 8 and 2 times 4. Now both of these give us a positive 8. So if it's going to be a negative 8, one of the sets of numbers has to be negative. So I just made it negative 1 and 8. Negative 2 and 4. It also could be 1 times negative 8 or 2 times negative 4. So you have that option as well. So which one of those 4 sets, when you add those numbers, you're going to get negative 7. 1 plus negative 8 would be negative 7. So this is what we're looking at. So we're going to replace the x and the y with 1 and negative 8. Doesn't matter the order because addition and multiplication are commutative, which means you can move them around. 1 times negative 8 is negative 8. 1 plus negative 8 is negative 7. Question 27, copy the figure on your paper, then draw any lines of symmetry. So remember, lines of symmetry, what we're trying to accomplish is to draw a line so that when we fold it over, it matches up on the other side. So obviously that first line I drew does not match up. You got a point here. It should match up with a point over here, and it does not. So we're looking for any lines of symmetry, however many you can possibly draw. So can we have a vertical line of symmetry? What about a horizontal line? What about diagonal lines? So it appears that maybe the only one that we can draw is going to be a horizontal line. And it's going to go the best I can, kind of get it right there in the middle. And that would represent your line of symmetry. So right through the middle of that shape. Question 28. Solve the equations below for x and check your solutions. Once again, making sure that we are checking our solutions on each of these. Part A, negative 3 plus 2x is equal to negative x plus 6. So we have variable terms and constants on both sides. So we got to work at getting one on each side. So I'm going to add x. That allows me to get 0 on the right-hand side plus 6, which would be 6. Add 3 to get the constant on one side and the variable term on the other. Divide by 3. X is equal to 3. And don't forget, you want to check these. So you should be plugging in wherever there's an x, a positive 3. Now this is a negative x, but so it's negative and then positive 3 plus 6, and then checking to see if they give you a true statement. So negative 3 plus 6 is equal to negative 3 plus 6. So obviously negative 3 plus 6 would be 3 on both sides, so yes, it does check. Alright, on to B. B is similar. We have 5 minus 3x is equal to x plus 1. So I'll subtract the x to both sides. That gives me 5 minus 4x equals 1. And if you do this in a different order, that's perfectly fine, as long as you are doing it to both sides and adding and subtracting correctly. And then when you do your multiplication and division as well. So I got negative 4 divided by negative 4 is x equals 1. And then, as always, let's go ahead and make sure this is the correct answer by plugging 1 back in to the equation and seeing if we get a true statement. 5 minus 3 is 2. 2 is equal to 2. So it does check. Alright, on to C. Now on C, we don't have a constant on the left side of the equation. So we want to be careful. We don't really want to add 2x to the other side. We'd rather subtract probably 4x. That way we have the variable term on the left and the constant on the right. Divide both sides by negative 6. You can either write it as a fraction, negative 3/2. You could write it as negative 1/1/2 or negative 1.5. Lots of different options there. They're all simplified, so they're all would be perfectly fine answers. And then to check, we're going to plug in. I'm just going to write it as negative 1.5. Plug those back in and see if, once again, we get a true statement. So on the right side, we get 3. And on the right side, on the left side, we get 3. 4 times negative 1.5 is negative 6 plus 9, so 3 is equal to 3. Once again, it does check, so we look good. And the last one, D, 4x plus 3. Now this time on the right side is equal to x. There's only an x term on the right side, so I don't really want to subtract that x. I'll just subtract the 4x. Even if it does give me a negative, that's okay. And then we can divide by negative 3. So negative 1 is equal to x, or x is equal to negative 1. And then we will verify by plugging negative 1 back in for x into the original problem. And that's negative 4 plus 3. Negative 4 plus 3. Fix that there, sorry. Negative 4 plus 3 is negative 1. Negative 1 is equal to negative 1, so it does check. So x is equal to negative 1. Question 29. Mr. Gua is thinking of a number. When he takes the absolute value of his number, he gets 15. What could his number be? Is there more than one possible answer? So remember what the absolute value represents. So the absolute value of a number is how far that number is from 0. So when he takes the absolute value of his number, it is equal to 15. What could his number be? Well, on a number line, 0, you have 15 over here. That would be an answer, but you also have negative 15. Both of those numbers are 15 units away from 0. So Mr. Gua's number could be two things. It could be negative 15, or it could be positive 15. And once again, make sure you're answering the question. So what could his number be? Could be negative 15 or 15.